I just went out and measured the diameter of the tires on my little Kia Spectra, and it was 24 inches. So the diameter of my tires was 24 inches. And I once got that car up to 105 miles an hour out in the out in Death Valley area of California, in the big desert out there. And so when I got up to 105 miles an hour, I'm curious, how fast were the tires spinning? Okay, so this is an example of problems with linear speed along the outside of a circle. And but I think more importantly, these problems which appear in your textbook, these types of problems, more important is to learn about dimensional analysis, how we calculate these problems using dimensions and units and so forth. So I'll explain that as I go along. But I'm going suppose I got that car up to 105 miles an hour, which I managed to do once. So 105 miles per hour. And I want to know the speed in the revolutions per second. How fast are the tires spinning in revolutions per second? Alright, so I've got to turn 105 miles an hour into revolutions per second. And the other information I have is that the diameter of the tire is 24 inches. So you know, imagine this, this tire rolling along, 24-inch diameter. Every time it spins once, it covers, you know, a certain amount of roadway, doesn't it? Every time. In fact, when it spins once along the road, it has traveled forward by the circumference, hasn't it? Circumference is distance along the outside of the circle. Spin the circle once along the road, the car has moved forward by the circumference. So the revolution of a tire on a car moves it forward by the circumference of the tire. Well, okay, so let's try to put all this together, all this information together. 105 miles per hour, and my diameter is measured in inches, so I got to convert miles down to inches. And let's see, now, I don't know how many inches there are in a mile, but I do know there are 5,280 feet in a mile. So I now have feet per hour. Those cancel. And of course there are 12 inches in a foot, so 12 inches per foot. And now I'm going inches per hour in speed. Now in terms of revolution, rotations of the tire, one revolution or one rotation of the tire is the circumference, 2 pi times the radius. 2 pi times, it is 2 pi times the radius, and the radius is 12 inches, not 24. Careful when you read these. So 12 inches. I could also put pi times the diameter. Pi times 24 would work just as well. Alright, well, I'm kind of running out of board space going left to right here, but now I'm up to revolutions per hour. And so I'm going to continue multiplying down below. So this is the hazard of working on my little board here. I don't have a lot of board space. So times, and what do I need? I wanted revolutions per second, and I have revolutions per hour. So I need to cancel hours. And in 1 hour, of course, there are 60 minutes. So those units cancel. This denominator cancels that numerator. And then finally, you know, 1 minute is 60 seconds. So the minutes units cancel. Alright, so you look carefully, and in class I would have this all the way across the board as one line instead of 2 lines. But look at how all the units canceled here, and I have revolutions per second. So we'll run this through the calculator, and I'm going to take, Telephone. I'm back. Alright, so let's do this calculation. And one mistake people make is in calculating with the denominator. So pay attention to this. Here's how I'm going to enter it. 105 times 5,280 times 12. Now that took care of the numerators. Now when I divide, I'm dividing by 2, dividing by pi, dividing by 12, dividing by 16, divided by 60. Whatever you do, don't hit divide by 2 times pi times 12 times 60 times 60. Your calculator will misinterpret what you meant. Now if you hit divide by and put in parentheses 2 times pi times 12 times 60 times 60, you would be okay as long as the denominator numbers were in parentheses. But if not, you've got to hit divide each time, which is what I'm going to do. So divide by 2, divide by pi, divided by 12, divided by 60, and divided by 60, and I get 24.5 approximately. So 24.5 revolutions per second. Well, okay, so let's write the answer. Now, if you're my student, I expect you to write sentence answers to word problems. So the tires spin at 24.5 times per second, or revolutions per second. All right, there we go. So that's an example of a linear speed problem. Okay, well, let's do another problem.